Alright, Trig review videos for our part 2 test. I'm going to start with these tangent problems. This first tangent problem, you can do both number 1 and number 2 with half angle or sum and difference. I'm going to do both with sum and difference. That's what I did on the key, and I think it's easiest to work with those with sum and difference. Because they're 12ths, sum and difference is doable. If you have an 8, like you have here with cosine on number 3, we'll use half angle there. But let's start with sum and difference for 5 pi over 12. The first thing we need to do is find two values on the unit circle that will add to 5 pi over 12 that we know. 5 pi over 12 is on the unit circle. It's actually between, let's see, it's a little less than 1/2, because 1/2 would be 6 pi over 12. So it's about right here. So we need to find two first quadrant values that are going to add to 5 pi over 12. Since that's not a value we have memorized, I'm just going to rewrite down here. And I usually do a little work off to the side to see what I can get toward here. So, or we can do it within the problem. So let's see, 5 pi over 12 could be 1 pi over 12 plus 4 pi over 12. And 4 pi over 12 would reduce, but 1 pi over 12 won't. So that combination will not work for us. We'll get rid of that and we'll try something else. 5 would be 3 and 2, so I could do 3 pi over 12 plus 2 pi over 12. That would equal 5 pi over 12. And both of those will reduce, and both of those will reduce the places on my unit circle. The nice time about using 3 pi over 12 anytime you can is that 3 pi over 12 is pi over 4, and we know tan at pi over 4 is 1. So that's a nice value to be able to put into our equation. 2 pi over 12 reduces 2 pi over 6. And now those are the values that we're going to put into our equation. Pi over 4 is our A, and pi over 6 is our B. And that order does not matter. So, our sum equation is tangent of the first angle plus tangent of the second angle all over 1 minus tangent of our first angle times tangent of our second angle. And I think sometimes when you're using these equations, it's helpful to stick that multiplication symbol in there. Alright, now we need to put our values in. Tan at pi over 4 is 1, and tan at pi over 6 is radical 3 over 3. In the bottom I have 1 minus. Tan at pi over 4 again is 1, and tan at pi over 6 is radical 3 over 3. Those values are really important to get right. You cannot get the rest of this problem right if you get those wrong. So something that you're going to want to do there is double check on your calculator. Since this is a calculator active unit, let's go ahead and use our calculator and check. And what I mean by that is make sure your calculator is in radians. So go to your mode button, make sure you're in radians if you have an 84. And then do tan of pi over 4 and make sure you get 1. And do tan of pi over 6 and double check. Now that's a nasty decimal, but that decimal is the same as radical 3 divided by 3. I would not do any more in the problem until you do those double checks. Because the rest of the problem we can't really do without you're not really going to do very much on your calculator except for double check. So you've got to be sure that you're not doing all that work for nothing. Okay, so I'm going to pretty this up a little bit. So I have 1 plus radical 3 over 3 on the top. And in the denominator I have 1 minus radical 3 over 3. Remember, we can only cancel if we have all multiplication. So don't try to make that -1 right now or do anything illegal and crazy like that. What we do need are common denominators in our numerator and denominator. So our 1s, we can use a fancy form of 1 here and change to 3 over 3 so that we have a common denominator both places. And I like doing that. And we can keep going. So my numerator is 3 plus 3, radical 3 over 3. And my denominator is 3 minus radical 3 over 3. What I'd like you to do is pause the video for a second and make sure that you do that division. So whether you flip the second and multiply, or whether you flip the second and multiply or group, flip the second, multiply, group, make sure you cancel your 3. So go ahead and pause and do that. Okay, when you did that complex fraction situation, whether you grouped or you flipped the bottom, what you found was that those 3's cancel. So you're rid of your complex fraction. You don't want to multiply those through. You want to cancel those 3's so that you have a simpler situation to work with. And we are almost there. All we need to do at this point is get rid of the radical that's in the denominator. So we have 3 minus radical 3. What we need to do is multiply by another fancy form of 1, and we're going to use the conjugate. So since this sign in the middle of the denominator is a negative, we are going to multiply, sorry about that, we are going to multiply by 3 plus radical 3. And if I'm doing that to the bottom to get rid of that radical, I have to do it to the top as well. And I'm going to FOIL on top. Here we go. 9, 3 radical 3, 3 radical 3. Radical 3 times radical 3 is square root of 9, which is 3. Or you can write it as square root of 3 squared and cancel there. Okay, in the denominator, our middle term should cancel, but I'm going to convince myself of that. Here's my minus. And be careful with your sign here. Negative times positive is a negative. Radical 3 times radical 3, again, is 3. So, just simplification work from here. What can we combine? In my numerator, I have 9 plus 3 is 12. And my other like terms are in the middle here. 3 radical 3 plus 3 radical 3 is 6 radical 3. In my denominator, my middle terms cancel. I have 1 positive and 1 negative, 3 radical 3. And then I can combine 9 minus 3 is 6. And then I can do that division. Make sure you divide both places. 12 divided by 6 is 2. 6 radical 3 divided by 6 is radical 3. We did all that work to find tangent of 5 pi over 12. And now we can double check. Here's another place you can use your calculator to be more confident or to double check your work. So I want to make sure that tan of 5 pi over 12 is the same as 2 plus radical 3. Whoa, it would help to put that in, right? Let's get rid of that guy. And put a radical there over that 3. And those are the same approximate values that your calculator gives you. All right, so that's number 1.